Here are a couple graphs where we look briefly at the free energy change in a chemical reaction versus its extent. If we have a situation where the free energy is negative, it's a spontaneous process, the overall change in a delta G will clearly be negative, and we're going to look at the extent of the reaction. Initially, Q is going to be far less than the equilibrium constant because the reaction is just starting off. However, it is getting favorable because we know that it is a spontaneous reaction. When you're at equilibrium, the change in the free energy should be at a maximum, and at that point Q is equal to K, and your formula can change at that point. And as you continue to form some products, typically the free energy goes up a little bit but stays overall negative. When you're dealing with an uphill battle, if you will, and the standard free energy is positive, a non-spontaneous reaction, as the reaction begins, typically you've overcome the activation energy, and typically the free energy goes down a little bit until it hits the equilibrium situation where Q does equal K. That is, the equilibrium constant is equal to the value Q, and then as it proceeds, things become unfavorable in terms of energy. It's non-spontaneous, and overall you can measure that it's a positive value. So this is just a couple quick looks at the free energy versus the extent of a chemical reaction.